Hello friends, myself Mr Narendra Jangale from Gokhale Education Societies RM Bhatt High School Parel. Welcome students. Today we are going to study SSC Class 10th Maths Part 2 third chapter Circle. From that third chapter today we are going to study that practice set 3.1. Students, before studying that practice set 3.1, we must study that basic concepts of circle. So dear students, let us see the basics of practice set 3.1. So in circle, we can't directly solve the practice set because so many basic concepts are required for that. So many concepts are related to circle. So we have to study that concept. First one is the circle. In circle, center, radius, diameter, chord, these are the terms related to circle. So what is meant by circle? How can we define the circle? Here, this circle is nothing but a set of points, infinite points. Here P point, D point, C point, A point, like this. So many points are there. So the set of infinite points which is at a fixed distance from fixed point. So here it is the fixed point and all these points are at a fixed distance from this fixed point. That set of points is called the circle. Now what is center? That fixed point from which all these points are at an equal distance, at a fixed distance, is called the center of the circle. So here, center of circle, the fixed point from which all the points are at an equal distance is called the center. In this figure, that O is the center of circle. Now next one is the radius. So radius of circle, if we observe the figure, the segment joining the center and the point on the circle, center and any point on the circle, center and any point on the circle, that is called radius of the circle. So we can define the segment joining the center of a circle and any point on the circle is called radius of the circle. So in this figure, this OP, OB, OA, all are the radii of the circle. And remember one important property of this radius, all the radii of the circle are congruent. Now next one is the chord, then we see the diameter. So chord is nothing but here CD and AB, these are the two chords. If we take any 2 point on the circle, the segment joining any 2 point on the circle, the segment joining any 2 point on the circle is called the chord of the circle. So we can define the chord. A segment joining any 2 points on the circle is called chord of the circle. So here this chord AB and chord CD are shown in the circle. Now diameter, the chord which passing through the center. How can we define the diameter? The chord which passes through the center is called the diameter. So here the chord AB is passing through the center of circle, therefore that chord AB is called the diameter of a circle. And you know, this diameter is the largest chord of the circle and diameter is twice the radius. These are some properties of the diameter. So remember this one. The properties of diameter. The first property of diameter is the largest chord of the circle, and second property, diameter is twice the radius. So sometimes the radius of circle will be given and find the length of largest chord of that circle. That type of question will be there. Then using this concept we can find that largest chord, length of the largest chord of the circle. So these are the concepts related to the circle, the circle, definition, radius, diameter and the chord. So see, before solving that practice set, you must see this or study these concepts. So let us see the next concept. The next concept here is the congruent circles. When two circles are congruent, we can measure the circle by the radius. It is smaller or larger, depends on the radii. So the circles having the same or equal radii are called congruent circle. Means circles having the equal radius are called congruent circles. That is the definition of circle. Means two circles are congruent, that means their radius are equal, their radii are equal. Now next concept is the concentric circles. Concentric means common center. So here there is a common center for all these circles, therefore these are called the concentric circles. So we can define the circles having common center are called the concentric circles. So in this figure, these three circles having the common center O, therefore these are called concentric circles. So this is the definition of concentric circle or concept of concentric circles. Now third point is intersecting circles. When two circles having 2 points in common, A and B, these 2 points are common for circle having center P and having center Q. So these are the two circles, different circles, and A and B are the 2 points common, then these are called intersecting circles and these are called point of intersection. So if two circles having 2 points in common, then these are called intersecting circles. So in this way, remember these three concepts. First one is congruent circles. If radius are same, then these are called congruent circles. Second one is concentric circles. Common center, then called concentric circles. Intersecting circles, if 2 points are common for two circles, then these are called intersecting circle. Now here we have to recall some properties of chords that we studied in 8th standard and 9th standard. So here the first property of chord is, if we draw a chord DE and if we draw a perpendicular from center to the chord and if we measure this DF and FE, then these are congruent. That means we can say the perpendicular drawn from the center of a circle to the chord bisect the chord. That is the property. So here in this figure, this CF perpendicular chord DE, therefore this segment DF is equal to segment FE. That is the property already we studied in 8th standard. So we have to recall that properties, we have to use that properties also. So remember, the perpendicular drawn from the center of circle to the chord bisect the chord means divide the chord into two equal parts. That's why here CF is perpendicular DE, therefore DF is equal to FE divided into two equal parts. So next concept or next property of this chord is here in this figure. This P is the center of the circle, AB is one of the chord. Now M is the midpoint of that chord. Now if we join the segment joining the center of circle and midpoint of the chord is perpendicular to the chord, that is the second one. Means here in first one, if perpendicular is drawn, then it bisect the chord means divide the chord into two equal parts, and here if we join the midpoint, then that segment is perpendicular to the chord. So the segment joining the center of circle and midpoint of the chord is perpendicular to the chord. That is the second property of the chord. The segment joining means in this figure, this PM, segment PM perpendicular chord AB. So in this figure, this segment PM is perpendicular to chord AB by this property. Now third property, the chords equidistant from the center of circle are congruent. Here two chords are given, chord AB and chord CD. Now OM is the distance of chord AB from center and ON is the distance of chord CD from center. Now if this two distance OM is equal to ON, here OM is equal to ON, then what we can write? Chord AB congruent chord CD. That means the chords which are at an equal distance from the center are congruent, and converse of that, if two chords are congruent, then these chords are at equal distance from the center of circle. If these two chords are congruent, then what we can write? So here we can write, if chord AB congruent chord CD, then what we can write? Segment OM congruent segment ON. So in this way, these are the four properties converse of each other of chord. So let us revise again fastly. Properties of chord. First one, if we draw the perpendicular from the center to the chord, it bisects the chord. That is the first property. Second property, the segment joining the midpoint of the chord and center of the circle is perpendicular to the chord. And next one, the chords which are equidistant from the center are congruent. And fourth one, if the chords are congruent, then these are equidistant from the center. So these are the properties of chords. We have to remember these properties while solving 3.1. Our next point is circles passing through 1 point, 2 point and 3 distinct points. So how many circles are passing if 1 point is given? If 1 point is given, then infinite circles are passing through that 1 point. If we draw one single point, then you can draw so many circles. So here infinite circles can pass through the single point. Second concept is here, if 2 points are given, here A and B are 2 points are given, then again we can draw the infinite circles passing through these two distinct points P, A and B. By taking AB as a diameter, we can draw one circle. Then AB as a chord. If we reduce the length of that chord, then that we can draw the infinite circle through two distinct points. Now third point, remember here, one and only if three non-collinear points are given, three non-collinear points like this A, B, C. If these three non-collinear points are given, then we can draw one and only one circle. We drawn this circumcircle of the triangle ABC. Triangle ABC means these 3 points are non-collinear points. Now we can draw one and only one circumcircle to triangle ABC. That means one and only one circle passing through the three non-collinear points. And if three collinear points are given like this A, B, C, then we can't draw the circle passing through these 3 points. So no circle can be drawn through the 3 collinear points. So remember this one, infinite circles are passing through a single point, infinite circle passing through 2 distinct points, only one circle passes through 3 non-collinear points, and no circle passes through 3 collinear points. Now the next concept is secant and a tangent. So when we can call the line is secant and the line is tangent. Now in this figure, if you observe the circle having center P, this line L intersect the circle in 2 distinct points. If a line intersect the circle in 2 different points, 2 distinct points, then it is called secant of a circle. So here we can define this secant, a line intersecting the circle in 2 distinct points is called secant of the circle. In this figure, this line L intersect this circle in two different points A and B. Therefore, line L is called secant of the circle, and this A and B are called point of intersection. Now, next concept is tangent. So, let us see here. One figure is given, tangent, and line M is given. The circle and the line having one and only one point in common. So, if the line touches the circle in one and only one point, then that line is called the tangent of the circle. If the line touches only in single point, then it is called, means there is single common point for circle and the line, then it is called tangent. If line M is tangent to the circle, here in this figure, line M is called tangent of the circle, and point T is known as point of contact. So remember this one. These are the definitions of tangent and secant that we already studied, but we are revising for solving that practice set 3.1. Remember, these are the basics of practice set 3.1. Now next one is a tangent theorem. Remember, no need to prove this theorem. That's why the proof is not written here. Only remember the statement and reason. Whenever we write the reason, when we use, we have to write tangent theorem. So what is that tangent theorem? Here, if we draw a circle, line L is a tangent at point T. So here, a tangent at any point of the circle. What is the statement of that theorem? A tangent at any point of the circle is perpendicular to the radius at the point of contact. Here line L is the tangent to the circle and T is a point of contact. If we draw the radius PT at point of contact, then this tangent is always perpendicular to this radius. So we can write PT perpendicular line L according to this theorem. This theorem is known as tangent theorem. So remember, radius is always perpendicular to the tangent at point of contact. So remember this one. In this figure, this line L is a tangent to the circle at point T, and therefore we can write PT perpendicular line L or line L perpendicular PT. So this is tangent theorem. Now what is the converse of that theorem? Let us see the converse. The proof of the converse is given here, already given in the book. So converse of tangent theorem. A line perpendicular to a radius at its point on the circle is tangent to the circle. Here a line L is given, and this line L is perpendicular to the radius at point N, means at a point on the circle. Then what we have to prove? That line L is a tangent. So what is given here? This M is the center of circle, segment MN is the radius, line L is perpendicular to the segment MN at point N, means at a point of contact. Then to prove that line L is a tangent to the circle. So here indirect proof is used. So take another point P on line L other than N. Take another point other than N on the line L. Here it is P, and join this MP. Now if we consider triangle MNP, in triangle MNP, this angle N is 90 degree, and you know, in a right angle triangle, the side opposite to 90 degrees is called hypotenuse. That means segment MP is the hypotenuse. Segment MP is the hypotenuse, and you know, in 9th standard we studied which one is the largest side in the right angle triangle. Hypotenuse is the largest side in a right angle triangle, and therefore this segment MP is greater than segment MN. Means this segment MP is greater than the radius. Here it is the radius, and here it is greater than R. Greater than radius means it is not on the circle, but segment MN is the radius and point P cannot be lie on the circle. It can't be on the circle. So no other point except this N is on line L of a line L is on the circle, and therefore line L intersect the circle in one and only one point, and the line which intersect the circle in one and only one point is called tangent to the circle. So in this way we can directly prove this one. So this proof is also not important. Remember only how to use these two theorems while solving the examples. The radius is always perpendicular to the tangent, and if we draw a line perpendicular to the radius at a point on the circle, then we can call this line as a tangent. Now let us see next. So here it is the first theorem from this chapter, and this is very important theorem. It may be asked in an exam as an activity or direct as a theorem. So here it is given as an activity, tangent segment theorem. So if we draw a circle and take a point outside the circle, if we draw any circle and if we take the point outside the circle, then you can draw how many tangents? Here we are drawing one circle. Here it is the circle, and here T is any point outside the circle. Then how many tangents we can draw? From D, this is one of the tangent, and here this is another tangent. So if the point is in the exterior, if the point is on the circle, we can draw one and only one tangent, remember. And if the point is in the exterior, we can draw two tangents. So remember this one, and we have to prove that two tangents drawn from an exterior point are congruent. That theorem is known as tangent segment theorem. So let us see tangent segment theorem. So this theorem is very important. So here what is given? Tangent segments drawn from an external point to the circle are congruent. So here D is in the exterior of circle, then DP is called the tangent segment. Here DQ is called the tangent segment drawn from exterior point. So we have to prove DP and DQ are congruent. That we have to prove. So here tangent segments drawn from an external point to the circle are congruent. That is the theorem. To prove that tangent segments drawn from an external point to the circle are congruent, that theorem will be there in an exam. Then we have to write the given, to prove, construction and prove. So what is given? In figure, D is a point in the exterior of a circle with center A. Now segment DP and segment DQ. Segment DP and DQ are the tangent segment from point D. Then what we have to prove? To prove segment DP equals segment DQ. Now we have to draw radius AP and radius AQ and this AD. Join this AD. So draw all these three lines. So in figure only, in exam what is given? This figure will not be given. We have to draw that figure. So draw the circle with center A. D is the point in the exterior. From that exterior point, DP and DQ are the two tangents. Now join this radius AQ, AP and this AD. Now the proof is already given. We have to fill in the blanks, means it is activity. So in triangle QAD, here it is triangle QAD and triangle PAD. Here can we write this PA is equal to this AQ. So here PA is given, we have to write is equal to segment, which one? AQ. Reason is already given, segment AQ. PA and AQ are the radii of the circle, and you know the radii of the same circle are congruent, and that's why we written here PA is equal to AQ. Now second step is already given. Segment AD congruent segment AD. What is the reason? Segment AD congruent segment AD in this two triangle, that is the common side. So here we have to write the reason only. It is the common side. The next one, angle APD congruent angle AQD is equal to 90 degree. So which theorem? Tangent theorem. That is called tangent theorem. What is the tangent theorem? The radius drawn at the point of contact is perpendicular to the tangent. Therefore, this angle is 90 degree, this angle is 90 degrees. So both are the right angle triangle. Now we get tangent theorem. Therefore, triangle PAD, here it is the common side. Here it is common side, and these two are the radii of the circle. So by which test triangle PAD and QAD are congruent? One hypotenuse and this one is side. So hypotenuse side test. Hypotenuse side test or theorem. By hypotenuse side test or hypotenuse side theorem, these two triangles are congruent, and if two triangles are congruent, their corresponding side DP corresponding sides of congruent triangles. DP and DQ are congruent. So in this way, this is very important theorem from this chapter. So see that theorem again. The tangent segment drawn from an exterior point are congruent. So first draw a circle with center A, and D is in the exterior. You can write the name of the point, any points. Here the names are not given. You can write any names, O, A, B, C, D, like this. Then draw the tangent from the exterior point. We can draw two tangents. So DP and DQ are the two tangent segments. Now join this AQ and AP radius and AD. Now we get two triangles, this PAQ, PAD and QAD. Now in these two triangles, PA is equal to AQ radii of the same circle. This AD congruent AD, it is a common side. Angle APD congruent AQD. By tangent second theorem, these are 90 degree, means both are right angle triangle. In right angle triangle, hypotenuse is congruent and radius means one side is congruent. So by hypotenuse side test, these two triangles are congruent, and therefore their corresponding sides are also congruent. So in this way we can prove this theorem. So this is the basic part for this practice set 3.1. Let us see practice set 3.1. Here it is the first sum from practice set 3.1. So what is given in figure? Radius of circle is 6 centimeter. Here CA is the radius of circle, so it is 6 centimeter. Line AB is a tangent at A. Line AB is a tangent at point A. Then what we have to find? What is the measure of angle CAB, this angle? Second one, what is the reason? Why? Means we have to write the reason. Second question, what is the distance of point C from line AB and why? Distance AB is equal to 6, then find BC. And what is the measure of angle ABC and why? So let us see one by one. So first one, what is the measure of angle? This CAB. This is the tangent. Line AB is the tangent and CA is the radius drawn at point of contact. And you know, by tangent theorem, this radius drawn at a point of contact is perpendicular to the radius, and therefore what is our first answer? Therefore angle segment CA is the radius and line AB is tangent. Therefore, angle CAB is equal to 90 degree. And reason, why? Why means reason. That theorem is known as, which theorem we use? Tangent theorem. So remember this theorem. Tangent radius drawn at point of contact is perpendicular to the tangent. So this is the answer of first one. Now answer of second one. What is the distance of point C from line AB? Here it is the C. Now CA, segment CA perpendicular line L. Now distance of point C from line L is nothing but distance CA or length CA, because CA is the perpendicular. The length of the perpendicular is called distance of that line from this point. So here CA is given, therefore distance CA is equal to, what is, 6 centimeter, because since radius is equal to 6 centimeter and CA is the 6 radius. So here we get the answer, radius CA is equal to 6 centimeter, means distance of that point C. Therefore distance of point C from line L is equal to 6 centimeter. We get the answer. Third point, AB is equal to 6 in this figure. If you observe the figure, AB is 6 and AC is 6. Now it is a right angle triangle, so use Pythagoras theorem. Now in triangle CAB, angle A is 90 degree. Therefore by Pythagoras what we can write? BC square is equal to AC square plus AB square. Reason, Pythagoras theorem. Here we can write the reason as Pythagoras theorem. Now BC square is equal to, hypotenuse square is equal to one side square plus other side square. Here it is 6 square plus 6 square. So 6 square is 36 plus 36 is equal to 72. So BC is equal to 72 means 36 multiplied by 2. BC square is equal to 72 means BC square is equal to, we can write 36 2. So BC is equal to, find the root, 6 root 2 centimeter. So BC we get 6 root 2 centimeter. So in this way, we using the Pythagoras we can find that BC. Now next one, fourth final question. What is that? What is the measure of angle ABC? This one, ABC. Here this BC is, we get 6 root 2, and here AB is equal to AC. Both are congruent, therefore, and it is right angle triangle, therefore it is 45 45 90 triangle. So in this way we can write the measure in triangle CAB, angle A is equal to 90 degree and AC is equal to AB is equal to 6 centimeter. Therefore, triangle CAB is isosceles right angled triangle, and therefore in isosceles right angle triangle the measure of these angles are 45 degree. Therefore measure angle ABC is equal to 45 degree. So in this way we can find the answers of all the 4 questions. So see again, the first one, we have to find measure angle CAB. It is 90 degree because tangent theorem. Tangent is always perpendicular to the radius at a point of contact using this concept. Second, this AB is 6, AC is 6, use Pythagoras, and then find this BC. In second one we have to find distance of point C from A. So length of perpendicular means radius is equal to 6, and at last we have to find this point. These are congruent, that's why it is 45 degree. So in this way this question number 1 is completed from this 3.1. So here it is, question number 2. Now read that question first, because so many means very lengthy question is there. Answer is short. In figure, O is the center of a circle. From R is in the exterior of the circle. From R, RM and Rn are the 2 tangent segments drawn from that point R and touching the circle in M and N. If OR is equal to 10, this OR is given 10, and radius of the circle is 5, means OM and ON, these are 5. Then what is the length of each tangent segment? Means we have to find this one. What is the measure of angle MRO? And then what is the measure of angle this MRN? That we have to find. Means this one and then this one. So let us see the answer. First, join this OM and ON here. Join. So first point, let us see the answer. Join OM and ON. Now if we join this OM, ON, this OM angle OMR is 90 degree. Therefore angle OMR is equal to 90 degree. The reason is tangent theorem. Remember this theorem. Only we have to use that theorem. No need to prove. This is tangent theorem. By tangent theorem, angle OMR is 90 degree. Now next point, in triangle OMR, angle OMR is equal to 90 degree. So this is a right angle triangle. In right angle triangle, use Pythagoras theorem. Therefore what we can write? Hypotenuse यानी opposite to 90. OR square is equal to OM square plus MR square. Reason Pythagoras theorem. So in this way, in this triangle we use Pythagoras. OR square is equal to OM square plus MR square. Now substitute the values. The values are given. OR is 10. So 10 square is equal to OM means radius 5 square plus MR square. MR is the length of tangent segment that we have to find. Therefore 100 is equal to 25 plus this MR square. Therefore what we can write? MR square is equal to 100 minus 25 is equal to 75. So MR square is 75. So we get MR is equal to 25 into 3. 25 3 means 5 root 3. How will we get? 75 can be written as 25 into 3. So root 75 is equal to square root of this one is 5 and root 3. So in this way we get this 5 root 3 centimeter or 5 root 3. So MR is equal to 5 root 3. Now third point. Therefore RM is equal to Rn is equal to 5 root 3 centimeter. Why? Both tangent segments are congruent. Reason here, tangent segment theorem. Tangent segment theorem. By this theorem, tangent segment theorem, the tangent segments drawn from an exterior point here. R is the point in the exterior. So Rm is equal to Rn. So using that concept, we get the value of, we get here Rm is equal to 5 root 3. 5 root 3. Now, we have to find measure of this angle. Now, fourth step. If we observe triangle OMR, so in triangle OMR, angle OMR is equal to 90 degree, means it is right angle triangle. OM is equal to half OR, because here it is 5 and it is 10. So half of that. So this side is opposite to which? 30 degree, and here it is root. And second thing, this MR or RM is equal to root 3 by 2 times this OR. If we substitute the value, root 3 by 2 into 10, 2 5s are, we get 5 root 3. So in this way, this is the 30, 60, 90 triangle, and therefore we can conclude that angle MRO is equal to 30 degree. MRO is equal to 30 degree by 30, 60, 90 triangle theorem. So here this side is half of the hypotenuse, that's why this angle is 30 degree. And second one, this angle is again 30 because both are congruent. Therefore angle MRN is equal to 2 measure angle MRO is equal to 2 into 30 is equal to 60 degree, because these two triangles are congruent also, and that's why we get the answer. It is 60 degrees. So let us see again how will we get the answer here. R is the point in the exterior, drawn segment RM and RN as a tangent segment from exterior point. ON radius is given 5 and OR is 10. Find this MR and RN. Both are congruent. So first use this concept. It is 90 degree by tangent theorem. So in triangle OMR use Pythagoras. By using Pythagoras we get MR is equal to 5 root 3. Therefore both tangent segment from exterior point are congruent. That is called tangent segment theorem. By that theorem both segment is equal to 5 root 3. Now in triangle OMR, this one angle is 90 degree, OM is half OR and MR is root 3 by, therefore angle MRO is equal to 30 degree and this angle is of 60 degree, twice of that. So in this way we can complete that second sum. Now let us see third sum. It is similar to that second one. Here segment RM and segment RN are the tangent segment of a circle with center O. Then prove that segment OR bisect angle MRN, means this angle, as well as bisect angle MON. Means we have to prove this angle MRO and NRO or ORM congruent ORN. This one, first step. And angle MOR congruent NOR. So that we have to prove. So here, the first step, join this in this figure also, that OM and ON are not given. So join OM and ON. So what about angle M and N? Therefore, angle OMR is equal to angle ONR is equal to 90 degree. Reason, which theorem? Tangent theorem. Radius is perpendicular to the tangent at the point of contact. Now, second point, if we consider these two triangles, these are right angle triangle. So in triangle OMR and triangle ONR. So here, this segment OM congruent segment ON. What is the reason? Radii of the same circle. So radii of same circle are congruent. This OR segment OR is congruent to segment OR. Here it is common side. Then third one, here if we don't write this one, no need to write this one, because by SSS that becomes congruent. We can use any. So here this MN and RM and RN are also congruent. Segment RM congruent segment RN. Why? This tangent segment theorem. Tangent segment drawn from an exterior point are congruent. Tangent segment theorem. So here no need to write this 90 degree because no use of that. We have written, but no need to write. Directly we can prove these triangles by SSS test. Therefore, this triangle OMR congruent triangle ONR by SSS test. And when two triangles are congruent, what about their corresponding angles in OMR and ORN? Let us see. This ORM and ORN, these are congruent. Corresponding angle, therefore angle, here we can write ORM congruent angle ORN corresponding angles of congruent triangles. And if these two angles are congruent, then we can write OR bisect. Therefore, segment OR bisect angle MRN. This first one is proved. Similarly, this second pair of angles, these two triangles are congruent. Therefore, this MOR and NOR. These are again congruent, corresponding angles of congruent triangle. Therefore, angle MOR, congruent angle NOR, is a corresponding angle of congruent triangles, and therefore segment OR bisect angle MON. That second is also proved. So in this way we can prove this third sum. So here this practice set 3.1 is completed. The video is become so large because the basic things are essential to solve that practice set. If you have any doubt, then write in a comment box. If you like the video, then press the like button and subscribe my channel and share the video to your friends. Thank you.